Welcome to all of you. Hopefully you all are doing very well. I've just returned from the theater watching Venom. Now it's 2:55 am and I am recording it for you so that you get it at 7 am today. So as you know, we upload a set video on every Sunday and on this Sunday also. So we are here with another set video. Before starting today's set video, let me tell you something on this context. Look, what I do usually is I post the question set on or 2 days before I upload the solution so that you can try to solve the problems. After trying them sincerely, and then if you watch the solution video, then only it will be helpful for you. Otherwise it will be of no work. So I request you to try the problems and match your answers on Sunday. So for the time being, let's start today's video. So this set 14 consists of questions from electromagnetic theory. So the first question reads: the values of the electric and magnetic fields in a particular reference frame in Gaussian units are E equals to 3x plus 4i and B equals to 3z respectively. An inertial observer moving with respect to this frame measures the magnitude of the electric field to be E prime equals to 4. The magnitude of the magnetic field B prime measured by him is. So this is basically an application of special theory of relativity. We have to know the transformation between different reference frames if they have some difference in velocities. Okay, so we know that Ex equal to 3, Ey equals to 4, and it has no z component, so Ez equals to 0. Similarly, Bx equal to 0, By equals to 0, and Bz equals to 3. Now look, if we go to apply the transformation rule, the transformation from electric field to magnetic field or magnetic field to electric field, then the calculation will become very lengthy and clumsy. I have tried that and I did not post it here. So I found alternative one, means using Lorentz invariant property, and I think the question setter wanted this to apply. So using Lorentz invariant property, we know that E square minus B square equal to E prime square minus B prime square. So E square means modulus of this. So 3 square plus 4 square equal to 25. So 25 minus 9 equals to 16 minus B prime square. Now this left hand side produces 16 and 16. So B prime must be 0. So it is matching with option 3. Let's go to question number 2. Consider a sphere S1 of radius r which carries a uniform charge of density rho. A smaller sphere S2 of radius a less than r by 2 is cut out and removed from it. The centers of two spheres are separated by the vector b equals to n cap r by 2 as shown in the figure. The electric field at a point p inside S2 is. So look, if I cut a sphere from this whole big sphere, then if we say that negative charges are inside this surface, then positive charge will be induced on the upper surface, on this surface. So basically, if we consider the charge density for this particular sphere, if we consider it positive, then the charge density inside this sphere will be negative. Okay, so basically the nature of the charges between these two spheres will be opposite. Okay, so as you can see, if you take this as origin, and this is the origin of the cutout sphere O prime, and this distance is denoted by this vector b, and this OP is denoted by r, and this difference vector is denoted by r prime. So O prime equals to b equals to this r by 2 n cap given. OP equals to r, this is also we assume, or yes, we assume. So electric field P at P due to S1 means due to the bigger sphere is E1 equals to rho by 3 epsilon naught r cap. R cap is the radial vector, radial. Okay, so electric field at P due to S2. So I told you that if the charge density for this bigger radius is rho, then the charge density for the smaller radius will be minus rho. So Et equals to minus rho by 3 epsilon naught r prime. R prime, this is the r prime, because for the smaller sphere we are measuring the distance from this point O prime. For the bigger sphere we are measuring the distance from O. Okay. So the resultant electric field at P inside S2 is E equals to E1 plus E2. This is the principle of superposition. So rho by 3 epsilon naught is taken common, R minus R prime. So rho by 3 epsilon naught into B. Now B is given as R by 2 n cap. So we replace the value of B here and we get E equals to rho R by 6 epsilon naught n cap, and it is matching with option 3. And I have shown the necessary calculations here. You can check it out. Now moving to question number 3. A loop of radius A carrying a current I is placed in a uniform magnetic field B. If the normal to the loop is denoted by n cap, the force F and the torque tau T on the loop are. Now as you can see, if you place a current carrying loop in a uniform magnetic field, then this loop will not experience any kind of force, but it will definitely experience some torque. Okay, so force on this is 0. So how many options we can discard? This option C and option B can be discarded so easily. Now the remaining options are A and D. Now we have to find out the expression for torque. Now what is the expression for torque? Torque equals to mu cross B. Mu is the magnetic moment and B is the magnetic field. Now torque equals to mu B sine theta, and mu equals to I A. I is the current, I A is the area. So I A n cap. Area as look, area is a vector and it has got some direction. So if we consider this is the plane of this slope, then the area is denoted, it's directed at this, along this direction, n cap. Okay, so putting this value of mu and keeping B as it is, we get tau equals to pi a square I n cap cross B cap. So it is matching with option 1. Next question, question number 4. This is from waveguide. A waveguide has a square cross section of side 2a. For the TM mode, transverse magnetic modes of wave vector k, the transverse electromagnetic modes are obtained in terms of a function psi of xy, which obeys this equation with the boundary condition psi at plus minus a, y equals to psi at x plus minus a equals to 0. The frequency omega of the lowest mode is given by. So we know that for transverse magnetic mode, the psi is given by this expression, a sine m pi x by a by a length is there, but here the length is 2a, so it is replaced by 2a into sine n pi y by a. Generally we place a means length or size of this waveguide. Here it is square of side 2a, so a is replaced by 2a, and m takes the value 1 2 3 dot dot dot. Now if you put this value of c and operate this operator on psi, you get a relationship like this. So you take double derivative with respect to x, double derivative with respect to y, and put these values in this equation, you will get this. And from here we get an expression of omega, and for lowest mode you know m equals to n equals to 1, so we get this expression for omega square, and it is fortunately matching with, I forgot to mention it, but it is matching with option 3, means this. Is it? Yes. Next question, question number 5. A hollow metallic sphere of radius a, which is kept at a potential V naught, has a charge q at its center. The potential at a point outside the sphere at a distance r from the center is. So potential at r equals to a is V naught. Suppose this is some sphere and this is the radius r, and the potential at this point is V naught. Why I am not able to write here? What happened to my pen? Okay, whatever it is. Okay, so potential at r equals to a is V naught, and solution of Laplace equation in this range r, this is suppose this is 0 to r, and beyond this the solution solution of Laplace equation in this region r greater than a. Suppose this is the radius a, and the solution of Laplace equation beyond this region given by this. Now as you know that V, the potential at infinite distance, will be 0. So if we put r equals to infinity here in this expression, what we get B equals to 0. So what is left? V of r equals to minus a by r, and therefore V naught, because at r equals to a, b equals to b naught, so b naught equal to minus a by a. So a equals to minus v naught a. So we have got the value of the constant. So v of r equals to plus v naught a by r, and is matching with option D, option 4. Now moving to question number 6. Consider a charge q at the origin of a three-dimensional coordinate system. The flux of the electric field through the curved surface of a cone that has a height h and a circular base of radius r, as shown in the figure, is. Now look, if you want to apply Gauss theorem, then we need a closed surface. But look, the q is situated here, so it is closed from the above surface, but it is not closed below the surface, so we cannot apply Gauss theorem here. Okay, so from according to Gauss theorem, E dot ds means total flux is equals to q by epsilon naught, total charge by epsilon naught. So what we are doing, we are trying to provide a closed surface. So we are considering another cone like this. So now it's making a closed surface. So the amount of flux which will be passing through this curved surface and this curved surface will be equal in magnitude. So phi curved surface plus phi flat will be q by epsilon naught. Now flux for the curved surface and flat surface should be same. So 2 into phi of curved surface equal to q by epsilon naught, means phi curved surface equal to q by twice epsilon naught, and it is matching with option 2. Now moving to question number 7. Given a uniform magnetic field B equals to B naught K, where B naught is a constant, a possible choice for the magnetic vector potential A is. Now what we do for such a question, we have to check each and every possible option. So as you can see, if we try with option 1, we get that it is equals to minus B naught K, but we have to get B naught K, so this option is discarded. Next we try with second option and we get B naught K, and it is matching with option B. So when you are sure that you don't have to calculate for these two terms because they have got for this term only, so this is the answer. Still I have calculated the other two and it gives 0, so it is not matching with this B naught K. So option 2 is the correct option. Now question number 8. A beam of unpolarized light in a medium with dielectric constant epsilon 1 is deflected from a plane interface formed with another medium of dielectric constant epsilon 2 equals to thrice of epsilon 1. The two media have identical magnetic permeability. If the angle of incidence is 60 degrees, then the reflected light is. So this is a straightforward question. Basically, if you know the what is the theorem, I forgot. Malus law. Yes, that is Malus law. Yes, Malus law. In that law, you must have seen this term Brewster angle. So what is, if some light, unpolarized light, incident on some dielectric media with this Brewster angle, then the reflected light is generally plane polarized and perpendicular to its vibration is perpendicular to the plane of incidence. So as you can see, for unpolarized light, it has got parallel components. This is the parallel component as well as perpendicular component, which is denoted by this dot, means vibration is perpendicular to this page. Okay, now when it is getting reflected, only the perpendicular component remains and parallel component is discarded. So it is vibrating perpendicularly, perpendicular to the plane of incidence. So this is the plane of incidence and it is vibrating perpendicular. Now we have to check that whether this angle 60 degree is a Brewster angle for this or not. So for that we know that the Brewster angle formula tan inverse n2 by n1. Now n2 and n1 is given, means dielectric constants are given, and as you know that the relation between dielectric constant and refractive index is this, n equal to root over epsilon. So we get the Brewster angle as 60 degrees. So and the light was incidenting at an angle 60 degree. Light was being incident at an angle 60 degrees. So it is the Brewster angle. So the reflected light must be plane polarized perpendicular to the plane of incidence. So option 1 is the correct option. Okay. So this is what I have said. Question number 9. A small magnetic needle is kept at 0, 0 with its moment along the x-axis. Another small magnetic needle is at the point 1, 1 and it is free to rotate in the xy plane. In equilibrium, the angle theta between their magnetic moments is such that. So if you want to visualize this problem, you can visualize it from here. So this is the magnetic needle is placed at 0, 0 and along the x-axis, as you can see the pointing direction. And another small magnetic needle is placed at 1, 1. So it's roughly 1 and it is 1. So 1, 1. Okay. So if it is 1, 1, then this angle joining the middle of these two needles must be 45 degree. Because it is a right angle and it is 1, 1, so it must be 45, 45 plus 90, 180. This is the property of triangle, that the three angles must be 180 degree. Now if it is 90 degree and the two sides are equal, then it must be 45, 45. Okay, this is not 45. This if you draw a perpendicular, then this angle will be 45 degree. Now the interaction energy of the two dipoles is U equals to mu naught by 4 pi r cube m1 dot m2 minus 3 m1 dot r into m2 dot r. Now this is the line of interaction of m1 and this is the line of interaction of m2. So the angle between them is theta, this angle. So if we expand this term, then we get a term like this. Now for a stable position in that equilibrium, this del u del theta will be 0 and so this thing will get derivative of cos theta minus sin theta and cos theta minus 45 degree, sin theta minus 45 degree. Now if we expand this sin theta minus 45 degree, we get this one, and if we divide the both side of this equation by cos theta, you get tan theta on this on the left hand side, and here you get 3 by 2 tan theta minus 3 by 2. So tan theta equals to 3 and it is matching with option 3. Now finally the last question of this set. A dipole of moment p oscillating at frequency omega radiates spherical waves. The vector potential at large distance is A of r equals to mu naught by 4 pi omega e to the power I k r by r into p. To order 1 by r, the magnetic field B at a point r equals to r into n cap is. So this is also a straightforward question. So magnetic field is given. Now you need to know about couple of information to solve this question, like what is the expression of P, how to write it in terms of R and theta. So as you know, B equals to curl of A. So this P we have to written it like that, P dot R cap into R cap plus P dot theta cap into theta cap. Now if you do, you can write P dot R equal to P cos theta and P dot theta equals to P sin minus P sin theta and theta cap. So this is the situation of this dipole. So this is a radius vector and we are calculating the field at this point P. So B equals to curl of A, and now if we have a vector A and we have to find out curl, and this is the standard formula, 1 by r square sin theta r theta r sin theta phi del del r del del theta del del phi. This is for this term, and here we get AR into RA theta into what I forgot, some phi related term is there, but there is no phi related term in this P for P, so we have to put 0 here. And for if we put this value of P here, then we see that the r term is on e to the power I k r into under cos theta, and here we have e minus e to the power I k r into sin theta, and here we r into a theta is there, and this term r into a theta is there. That's why we see that this r has gone for the second term, and for phi related term it is 0, so it is 0. So if you calculate it, you get that two terms, one is depending on 1 by r, and another one is depending on 1 by r cube. But we have to they are asking about 1 by r term to order 1 by r, so we'll take this first part only. So up to 1 by r order you get this. Now omega equals to ck, so putting the value of omega here, so k equals to omega by c, so omega square by c e to the power I k r by r p sin theta phi cap. So we kept it as it is. Now we have to look at the options. So an option we got n cap cross p, n dot p. So we'll try n cap cross p. So what is that? N cap cross p equals to, so n cap is minus r cap into p equals to p sin theta cap. Look why it is so. So we have taken the cross with p, so n cap means r cap, so r cap cross r cap will give you 0 because sin 0 is 0. So as you can see, r cap cross r cap, so it is giving 0. So the remaining term is this minus p sin theta. So that's why a minus sign is there, minus p sin theta and theta cap. So r cap cross theta cap is not giving 0, and it is surviving, it is giving phi cap, r theta phi. Okay, my pen is very weak, it cannot write so much. So r theta phi, it has got some clockwise relation. If you take cross product with r theta, you get phi r theta phi r. It's like x y z, x cross s cap cross y cap equals to z cap, y cap cross z cap equals to x cap, z cap cross x cap equals to y cap. It's just like that. So we get minus p sin theta phi cap equals to n cross p, so we just replace it to match the option. So minus mu naught by 4 pi omega square c into n cap cross p equal to the power I k r by r, and fortunately it is matching with option 2. So my request that don't take risk to solve such question at examination hall. So my suggestion would be avoid this electromagnetic stuffs. Few questions you can do easily, like Coulomb gauge, Lorentz gauge, those type of questions are very easy to answer, but this type of clumsy calculation you should avoid unless and until you are so much confident about your calculation power, because this type of question may waste your time and you will lose marks. You may get negative marking also, there are high chances. So try to avoid them. You try this type of question at the last half an hour. Okay, so we have finished set 14. So set 14 means 14 into 10, 140 questions. So we have solved 140 question on our channel. Okay, so this is all for today. If you like the video, please give a thumbs up, and if you are new here, please subscribe the channel and don't forget to press the bell icon. And if you have any confusion, query, suggestion, you can comment down below. Every suggestion will be appreciated. And what you can say, finally, thanks for watching.